Dr. Francis O. Aweda. I'm to demonstrate experiment 5 for you, and the title of the experiment is Determination of the Acceleration Due to Gravity Using a Simple Pendulum. The aim of the experiment is as shown also as a title. And for this experiment, what is required of you, we have the meter rule, the stopwatch, the pendulum bob as shown, your thread, split cork, and the record stand. So for these experiments, as shown on the board, you can see this is the setup of the experiment. You have your meter rule, as I said earlier, your pendulum bob, your split cork, and the thread. So for this experiment, we know that from our knowledge, our theoretical knowledge, we have this simple formula, and which is T equals to 2 pi square root of L over G. And we know that our T is a period, where our L is the length of the thread, and G is the acceleration due to gravity. Mathematically, we are going to have, removing your square root, we are going to have your T to be T squared equals to 4 pi squared over G multiplied by L. And you remember from your equation of a straight line that y is equals to mx, where your y simply means your T squared, which is the period, and your x, which is the length, is the same thing as the length of the rope, where our m is our slope, and the slope is equals to 4 pi squared over g. For this experiment, we know that there is no intercept, and since there is no intercept, our c will be equals to 0 from equation of a straight line. So coming back to this, we have our table, but before we have our tabular reading, we have our setup for this experiment. And from this setup, this is our pendulum bob, the rope, and the record stand. This is my meter rule, my stopwatch as shown. So we are going to measure different lengths of this thread. And as displayed on the board, we have 95, 85, 75, and 55 which is in centimeter. But for your experiment, you are going to convert this centimeter to meter. As you know, your meter rule is measured in centimeter. Then you convert this to meter. So for this 95, you are to measure the length of this rope from the tip of this split cork to the middle of your pendulum bob. Let's say this is the mid of the pendulum bob. I have it as 95 centimeter. Having said that, before you display this, you should put it at the back of your mind that we are going to use a 20 complete oscillation for this experiment. And having said that, you displace your pendulum bob at a certain angle. So this is the displacement, and before you start your stopwatch, you displace it. When the bob gets to the maximum, then you display the stop, or you press the stopwatch. I release my pendulum bob. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. However, for this experiment, you are to stop at 20. I intentionally did that just to let you understand what it's all about. So as soon as I get to 20, I press my stopwatch, then I put the record of what I have done on the board. This, let's say I have the value, I write the value. After I've written the value, then from my slope, we are to plot the graph. We are to plot a graph for these experiments. And for this, the plot of this graph, we are to have something like this: your t squared in seconds squared, and your length, which is in meter. As I said earlier, that you convert this to meter. Why? Because you know your acceleration due to gravity is measured in meter per second squared. So for these experiments, you are to measure or determine the value of your t, which is in seconds. You are to determine t1 and t2, whereas you are to determine the value of your t average, which is the mean, t mean, as shown on the table. After you have done that, you will determine the value of your period, which is your t. And you know that your period is the value of t divided by the number of oscillation, your complete oscillation. Then you calculate the value of your t squared, which is in seconds squared. After you have done that, you plot your graph. Your t squared, which is on the y-axis, your length in meter, which is on the x-axis. But before that, you know that for this experiment, you have your 95, 85, 75, 65, and 55 values. You are to vary the length of your thread in 10 centimeter interval as shown on the board. More so, by determining your t squared and the value of your length in meter, you are to use it to plot your graph. But however, for this experiment, what you want to determine your acceleration due to gravity, which is your g. So from this, you've gotten your slope. You remember from your equation, this equation, let me label this equation 1, and this as equation 2. From your equation 2, you know that your slope is equals to 4 pi squared over g. So therefore, my slope will be equals to 4 pi squared divided by g. You know the value of your slope, then it will be easier for you to determine the value of your g. Whereas you are going to make your g as subject of formula. Then you have something like this: g is equals to what? 4 pi squared divided by your slope. So for this experiment, this is the value of your g. I think you understand. Thank you.